and welcome to Edusathi. Continuing the topic of algebra, we'll be moving to the topic of coordinate geometry. Just look at what you have on your screen. Two real number lines that are perpendicular to each other and that intersect at their respective 0 points define a rectangular coordinate system. Often, it is also known as the XY system or the XY plane. Now here, the horizontal number line is called the x-axis. On the right hand side of 0, you have positive x-axis. On the left hand side of 0, you have negative x-axis. The vertical line that we have is known as y-axis. The point where the two lines intersect, this is the point. This point is known as origin. This point is known as origin and it is denoted by O. Now the coordinates for origin are 0, 0. What does that mean? X coordinate is also 0 and y coordinate is also 0. Now the two axes that are there, they divide the entire region into 4 parts. And these 4 parts are known as the 4 quadrants of XY plane. Now if you look here, these are the 4 quadrants that are there. Quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Now whenever a point is marked in these coordinates, it is always written as an ordered pair XY. Now if a point P has to be marked, it will be written as PXY. Here, this X would refer to X coordinate and the second one would refer to Y coordinate. This means this X refers to the distance that it is located from the origin. So on x-axis, at what distance is the point located from the origin is what the x coordinates tells you. If the x coordinate is positive, that means the distance that has to be taken on the right hand side. If it comes out to be negative, that means the distance of this many units have to be taken on the left hand side. Similarly, if I talk about y coordinate, I find if I take a modulus, this will tell me how many units above or below the x-axis is the point located with respect to origin. Again, if it is positive, it will be upward. If it is negative, it will be downward. The origin has coordinate 0, 0, so everything is measured in reference to the origin. So if I take this point P42, that means it is at a distance of 4 units positive from the origin on x-axis. So on x-axis, I move 4 units and then it is at a distance of 2 units from origin on positive direction of y-axis. I reach here. I draw a line perpendicular to this, parallel to this, and I draw a line parallel to y-axis. This point refers to the point P42. It is 4 units to the right of y-axis. It is 4 units to the right of y-axis and it is 2 units to the upward of x-axis. That is what the point P. Similarly, you can look at any other points. Let's look at P triple dash. It is -4 and 2. So it is located at -4 from y-axis and -2 from x-axis. So that means if I look at it from y-axis, it is located at a distance of -4. From x-axis, it is located at a distance of -2. This is the point that I get as P -4 -2. I hope you are clear about how coordinate axis looks like. Let's look at the first formula that we have in coordinate geometry. The first formula, which is a very, very important formula, is the distance formula. The distance between any 2 points on the xy plane can be found out by using this distance formula. So any 2 points, I can label them as x1, y1 and x2, y2. These are any 2 points. So if I have to find out the distance between the 2 points, I will use a distance formula. Distance formula actually is the concept of Pythagoras theorem. So you can remember the formula. The formula is x2 minus x1 whole square plus y2 minus y1 whole square root. It's actually an application of Pythagoras theorem only. So this is the formula that you will be using in order to find out the distance between any 2 points in the coordinate axis. Let's take an example. If I want to find out the distance between the 2 points minus 2, 3 and 4 and 1.5. Let's look at the figure that you can draw. So this is the coordinate axis that you have. You plot the points minus 2 and minus 3, that will be a point here, minus 2 and minus 3, and 4 and 1.5 this is. And if you join QR, QR is the length of the line joining the 2 points which I want to find. So the distance formula would give me the length of the line QR. I can just apply the formula 4 minus minus 2, 1.5 minus minus 3, square it and take the square root thing, and I will land up with my answer. The answer that I get is 7.5. The distance between the 2 points is coming out to be 7.5. Now if you look here, how I actually do it is, I try to create a right angle triangle. So if I look at it, this will be the base of the right angle triangle, which is actually the length of the line between the two x values. So this is x2, this is x1. If I subtract the two values, x2 minus x1 would give me the distance of the base. And the length of the perpendicular would be the difference between the two y values. So if I just square it and take the under root sign, will give me my answer. I hope the distance formula is clear to you. Let's move ahead and let's look at the section formula. Section formula helps us in finding the coordinates of any point on the line that divides the line in some ratio. And that sum ratio that I'm taking generally is m is to n. So if I just take an example, this is the point x1, y1, this is the point x2, y2. There's any random point xy on the line which is actually dividing the line in some ratio. That ratio could be, let's say, 2 is to 3 or 1 is to 4 or 1 is to 1. So in general, I write m is to n. Now I have to find the coordinates of this point. This is where the section formula will help me out. Section formula is, what I need to do is, I just need to multiply this m that you have with this coordinate and n with the first coordinate. So it's like cross multiplying the thing. So my answer would be, my x coordinate will be m into x2. So what I'm doing is m into x2 plus n into x1 plus n into x1 over m plus n. So this is the total parts in which the line is getting divided. Similarly, my2 plus ny1 over m plus n. my2 plus ny1 over m plus n is what I get as my formula. Now if you note, there is a plus and a minus sign. The plus sign is to be used whenever it's an internal division. Internal division means this point lies on the line. Lies on the line xy, lies inside the 2 points x1, y1 and x2, y2. If this point xy lies on an extended line, so for example, if I take this same thing, this is x1, y1 and this is x2, y2. Now this point xy does not lie inside this line, but it lies on the extended. So if I have to then find out the coordinates, I will again do the same thing. So it is dividing it in the ratio m is to n. That means this is m and this total is n. The distances are measured in reference to xy. So again, it will be the same thing that I'll be doing. M will be multiplied with x2, y2 and n will be multiplied with x1, y1. And instead of a plus sign, I will use the minus sign. Midpoint formula, which is an extension of the section formula, says to find out the coordinates of the midpoint of the given line, I would just simply put m is to n as 1 is to 1. So if I just put it out, it will be x2 plus x1 by 2 and y2 plus y1 by 2. So if there is a line, the coordinates of the midpoint will be given by the average of the x coordinates and the average of the y coordinates. That will give me the points, the coordinates of the midpoint of the given line. Let's talk about a triangle now. Look at your screen. You could see a triangle. I can just, label the triangle as well. Capital ABC refers to the angles and small ABC would refer to the side length. So the length of the side BC would be small a, the length of the side AC would be small c, and the length of the side AB would be referred to as, I have labeled it incorrectly. This will be A, this will be B, and this should be C. Now how the labeling is done, the angle and the opposite side are proportional. So if I know this side is A, the angle opposite to this would be A. If I know this side is C, the angle opposite to this would be capital C. This side is B, the angle opposite to this would be capital B. So the angle is proportional to the opposite side. The greater the opposite side, the greater will be the angle opposite to it. So in case of a triangle, I have the formula to find out the centroid of a triangle. Now what is centroid? Centroid of the triangle is the point of intersection of all the medians. Now the point where all the medians intersect is known as centroid of the triangle. To find out the coordinates of the centroid, if all the coordinates of the three corners of the triangle are given, the formula that I would be using would be the x coordinate will be given by the average of all the x coordinates, which will be x1 plus x2 plus x3 by 3. And the y coordinate would be determined by the average of y coordinates, which is y1 plus y2 plus y3 by 3. So it is the average of x coordinates that give me the x coordinate for the centroid, and the average of y coordinates that give me the coordinate for the y coordinate for the centroid. The next thing that we'll be learning is how to find out the incenter of the triangle. Now, incenter is the point of concurrency of angle bisectors. So if you draw the three angle bisectors and if you make them intersect at a point which is known as incenter. Now the incenter of a triangle is given by, it's a little complex formula, so you need to be very careful when you're applying the formula. Small a, B and C refer to side lengths. So this side length will be multiplied with the opposite vertex. So A would be multiplied with x1 plus B would be multiplied with B is here. B would be multiplied with x2 and C would, just what you have to do is just multiply it with an opposite vertex. C would be multiplied with x3 over A plus B plus C. So what you are just doing is you are multiplying it with an opposite vertex. Maybe the vertex here are not labeled as in the formulas. So what you just have to do is, if you take B would be multiplied with this, C will be multiplied with an opposite vertex divided by A over B over C. A plus B plus C. Similarly, A y1, B y2, C y3 over A plus B plus C would give you the y coordinate for the incenter of the triangle. Area of the triangle. If all the three vertices are known to you, you can directly apply the formula for area of the triangle, and that formula is given as half x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So if you look here, there is no modulus sign that you have in the formula. So you need to be very, very careful when you're applying the formula, because a little bit goof up with y1, y2 and y3 could end up giving you a wrong answer. So what you have to do is you have to be very, very careful. After 1, 2 should come. After 2, 3 should come. After 3 again 1 should. So it's like a circle that you enter. So it's 1, 2, 3. So again, if it's 2, it should come 3 and it should come 1. If you start with 3, it should be 1 and 2. It should be a cyclic thing that will give you your answer. Moving ahead, we learned how to find out the equation of a line in a coordinate plane. So this is very, very important. Equation generally on a coordinate plane, which is an xy plane, would be represented in two variables. Now, one variable would be x and the other variable would be y. So the graph of an equation is actually all the set of ordered pairs of x and y which satisfies the equation. So if I try to make a graph, every point on the graph would be satisfying the equation of the line and would actually be a solution set for the line. So how I need to look at is the graph of a linear equation because it's a line that I'm talking about, is of the form y is equal to mx plus b. And it's a straight line in an xy plane. You have to be very, very careful. It should be always a straight line in an xy plane, where m is known as the slope of the line and b is known as the y-intercept. So general equation would be y is equal to mx plus b. M here refers to the slope and b here refers to the y-intercept. What is a y-intercept? Y-intercept of the graph is the y-coordinate of the point at which the graph intersects the y-axis. Let's look at the graph first. So let me just look at the graph that we have here. Now, here if I look at it, the graph cuts the y-axis at 5. So the distance between the origin and the point where it cuts the y-axis is known as y-intercept. Similarly, the distance between origin and the point where it cuts the x-axis would be known as x-intercept. So if I look at this equation of the line, y is equal to 2x plus 5. So, and if I just compare it with y is equal to mx plus b, that means the slope of this line is plus 2 and the y-intercept is plus 5. So it will be cutting the graph at a positive direction in the y-axis at 5 things. Okay. Now, the slope of the line passing through 2 points. If I know the 2 points, I can always find out the slope of the line passing those 3 points. And it would be given by y2 minus y1, which is the difference in y coordinates, over x2 minus x1, which is the difference in x coordinate. This ratio is often called as rise over run, where rise is the change in y while moving from x2 to x1 or while moving from x1 to x2. So this is very, very important thing that we have. This is change in y over change in x coordinate, also known as rise over run. If you have a horizontal line has a slope of 0 because there is actually no difference in the y coordinates when you are moving from x1 to x2. And if you have a vertical line, the slope of a vertical line is not defined because at the same given point, there can be multiple values of y that you can take. So again, discussing the same thing, let's look at the graph that we have on the right. So these are 3 lines. If 2 lines are parallel to each other, they would have the same slope. So if I just look at y is equal to mx plus b, the slope which is referred to as m is 2. Again, the slope which is there is referred to as 2. So if the slope of the two lines is equal, if m1 is equal to m2 that you have, the two lines would be parallel. If the two lines are parallel, they would never ever meet, they would never ever intersect, or they would never ever have a common solution. If you remember, we have done this when we were talking about linear equations. So if two things are parallel, I technically have no solution because they would never ever intersect. So let's look at the thing. As already discussed, horizontal line has a slope of 0. So the equation would be y is equal to, there's no m, so it's only y is equal to b. A vertical line, there's no slope which is defined for it because for the same value of x, there are multiple values of y that you have. So the equation for a vertical line becomes x is equal to a. Every point on this line will only have one thing fixed, which is the x coordinate. Y coordinate will keep on changing, but the x coordinate will remain fixed. If two lines are parallel, their slopes are equal. Now this is what is very interesting here. If the two lines that are given to you are perpendicular, if the two lines are perpendicular, their slopes are negative reciprocals of each other. Or in simpler terms, I would say the product of their slopes is minus 1. If two things are perpendicular, the product of their slopes is minus 1, or one slope is the negative reciprocal of another. So if I look at this line, m3 is minus 1 by 2. So if I multiply m3 with m2, I would get a product which is minus 1. So I would put a small square here telling that these two lines are perpendicular to each other. Now let's discuss how to write down the equation of the line. So the various forms in which an equation of the line can be written. The first form is slope-intercept form. That means I should know the slope of the line and I should know one of the intercept. The intercept that I need to know here is the y-intercept, which is represented with the symbol b. So the equation of the line would be written as y is equal to mx plus b. The other way that I can form the equation of the line is when a point and the slope of the line is given to me. So I have a point x1, y1 and the slope of the line given to me. So the way in which I will write the equation would be y minus y1, which is the point, the y coordinate for the point which is given to me, equal to m slope into x minus x1. So this is the way that I will be writing the equation of the line. Here x and y are the two variables that need to be in the form of x and y only. I need to fill in the value of x1, y1 and the slope m. The other way that I can form the equation of the line is when 2 points are given to me. So there are 2 points x1, y1 and x2, y2 which are given to me. I need to find out the equation of the line. I would follow the similar thing only with the change that m, which is the slope of the line, would be calculated separately. M is written as the change in y coordinate over change in x coordinate. So y2 minus y1 over x2 minus x1, this m would be replaced with the value of m. And y minus y1, which is the left hand side, would remain the same. And this m into x minus x1. To intercept, if both the intercept, the x-intercept and the y-intercept are given to me, then I can write down the equation as x over a, this is the x-intercept, plus y over b equals to 1. I need to fill in the values of a and b. That means I need to fill in the values for both the intercepts. So these are the various ways in which the equation of the line can be written. Which equation to use will depend upon what is given to you in the question. Now let's look at some of the examples based upon coordinate geometry. The first example that we have is, in an xy plane, the slope of the line passing through the points minus 2 minus 3 and 4 and 1.5 is. That is the question that we have. So I just know this is x1 y1 and this is x2 y2. Now the slope of the line would be given by change in y coordinates over change in x coordinates. That is the value that I have. So it will be, you can take 1.5 minus 3 over 4 minus 2. So this will be 4.5 over 6, which comes out to be 0.75. So what is the slope of the line? 0.75. It's a positively sloped line that I have. So it's a positively sloped line that I have. Let's look at another question that we have. Consider the system of linear equation in two variables. So these are the two variables that you have, and I have to solve this. This solve could be graphically also, or this solve could be any ways I have to solve the thing. I'm just doing it graphically because I just need, I want you to understand how the equations look if you draw them on the graph. Now, these are the two linear equations. This will be a linear equation with a slope. If I just try to fill it in the way, 3y is equal to minus 4x plus 13. I'm trying to get it into the equation y is equal to mx plus c. So y is equal to minus 4 by 3x plus 13 by 3. So here I would look at it, what is the value of f of m, or the slope is minus 4 by 3. So if I look here, 2y is equal to 2 minus x. So y is equal to, I can write it as minus x plus 2, minus x plus 2 by 2. So the value that I will get will be minus 1 by 2x plus 1. So the slope that I get here is minus 1 by 2. Since the slopes I will refer to as m1 and m2. Since m1 is not equal to m2, that means they will intersect for sure. And when they will intersect, I will have a common solution to both the equations. Common solution, or it will be a unique solution for both the equations. Now I can do it normally. Normally, how do I do it? I make the coefficients of any of the variables same. I subtract it and I find out the value of the other variable. So for example, if I multiply this equation with 4, okay, and I subtract this minus this, 4x and 4x will get cancelled out. This will be 8y minus 3y. So I'll be left with 5y equal to, this will be 8 and this will be 13. So 8 minus 13, which will be minus 5. So the value of y that I will get would be minus 1. Putting it in any of the equation, I put it here or in the previous equation, x plus 2y or x minus 2 is equal to 2 or x is equal to 4. So the answer that I have is 4 and minus 1. This point is such a point that is satisfying both the equations simultaneously, also known as the solution of the system of the equations. This solution is the point where the lines meet graphically. So if I try to draw the graph, this is how it will look like. This is the graph for 4x plus 3y equals to 13, and this is the graph for x plus 2y equals to 2. So the two graphs would definitely intersect at a point which is 4 and minus 1, which is the common solution that I have for both. Let's look at another question. Consider the following system of linear inequalities, and I have to solve each inequality for y. So it can be solved graphically, or the graph could be given to you, or it could be solve the thing, or it could be the various points which are given to you. You have to find out which of the following point is a solution for this inequality. Or there are 4 sets of graphs which are given to you and you have to find the correct graph. So the question can be anything. So when you have a question like this of an inequality, we treat it like an equality. So what I'll do is I'll look at the graph in terms of equality only, and then I would try to see which side would the equality which side would the inequality will hold true. So what I have to do is solve each inequality for y in terms of x. So if I just find out for y in terms of x, the first inequality would look something like this, and the second inequality would look something like this. Now each point xy that satisfies the first equality is either on the line, this line, equal to or below it, because y coordinate is either equal to or less than this. So every point which has to be satisfying this has to be either on the line or below it. Okay, so therefore the graph for this would constitute of the line and all the region below it. Similarly, the graph for y greater than or equal to minus 2xi, minus 2x minus 1 consists of line and the entire region above it. So y has to be greater than region above it. Thus the solution set of the system of inequalities would consist of all the points that lie in a common region. That means below this line and above this line. So in a common region, so if I try to draw these lines and plot the common region, this is what it will look like. So this is the line which is y is equal to 1 by 3x plus 2. And every point below this would come here. And this is the other line which is y is equal to minus 2x minus 1. Every point above it. So above it, this is the common region that I get. This common region, every point in this common region would be actually a solution set of this system of inequalities. So every point here would be a solution set to this region. Okay. The next thing that we'll be looking at is the reflection and the line of symmetry. This line of symmetry is a very, very important thing that we have. So first we look at reflection. This reflection could be across x-axis or across y-axis. This reflection could be across anything. Here, if the reflection is across x-axis, then x-axis will become the line of symmetry. So that means, howsoever is the graph above the line of symmetry, the graph would be same below the line of symmetry as well. So if I just look at it, if x-axis is the line of symmetry and the graph that I have is y is equal to mx plus c, it will be reflected across x-axis. That means it will be similar. If I just fold this thing over x-axis, I would get this thing. I would get a thing like this. So what happens is, on a reflection across x-axis, the slope becomes negative and the intercept, which is the y-intercept, also becomes negative. Negative means if it was initially positive, it will become negative. If it was initially negative, it will become positive. So there's a minus sign or there's a negative relationship that I have in both the slope as well as the intercept. So if this was the original intercept, it will become this, and if this was the original slope, it will become the other way around. So the slope would also become negative and the intercept will also become negative. Both will change their sign. However, the magnitude will remain the same. Reflection across y-axis. Now, if the reflection is across the y-axis will become the line of symmetry. So, y-axis will become the line of symmetry. The slope will be changed, but the intercept will remain the same. So if you have y is equal to mx plus c, it will become y is equal to minus mx again plus c. What do? I fold the thing across the y-axis. So whatever is there will come here, and whatever is here will come the other way around. It's just like folding across y-axis, or it is also known as getting the mirror image. The farther away that you are from the mirror, the reflection will also be farther away from the mirror. So this distance would be equal to this and this distance would be equal to this. It's just like getting the mirror image. Let's look at a question. Consider the line whose equation is y is equal to 2x plus 5. What would be the equation of the line reflected to this line along the line y is equal to x? So if I just look at this, the equation which is given to us is y is equal to 2x plus 5. So what I have to do is I have to reflect it around x is equal to y. So whenever there is a reflection around the line y is equal to x, I would interchange x and y. I'll get x is equal to 2y plus 5, or y is equal to minus 1 by 2x, 1 by 2x minus 5 by 2. So this line is a line of symmetry for this graphs that you have. So if you have y is equal to 2x plus 5, interchange x and y and get the equation y in terms of x. So this will be a symmetrical. Whatever is the distance here, the same will be the distance here that I have. So y is equal to x will become the line of symmetry. Parabola. The graph of a quadratic equation. I hope you remember the quadratic equation. It was y is equal to ax squared plus bx plus c, where a, b and c are constants and a is not equal to 0, is a parabola. The x-intercept of the parabola are the solutions of the equation. So if I just put this thing equal to 0, or if I put y is equal to 0, then the x-intercept of the parabola becomes the solution to this. They are also known as roots of this equation. I hope you remember this. We have done when we were doing the concept of the concept of quadratic equation. The x-intercept of the parabola are the solutions to the equation ax square plus bx plus c is equal to 0. If a is positive, the parabola opens upward and vertex is the lowest point. So the graph would look something like this. The vertex is the lowest point. If a is negative, then the parabola opens downwards, and again vertex here becomes the highest point. Okay. Every parabola that we have is symmetric with itself about a vertical line that passes through its vertex, and this vertical line passing through the vertex is known as the line of symmetry. So this line here, this line here, this line is known as line of symmetry. And in particular, the two x-intercepts, or I would say the two roots that I have for a quadratic equation, are equidistant from the line of symmetry. So if I know the line of symmetry, the two roots that I would have would definitely be equidistant from this line of symmetry. So if you go back to what we have done in quadratic equation, we have done that if a is positive, the graph would be upward opening. If a is negative, the graph would be downward opening. And the graph would not touch or cut the x-axis if your discriminant, I would write it as discriminant is negative, because then you have imaginary or unreal roots as your answer. The second case that we have discussed was when your discriminant b square minus 4ac comes equal to 0. That means you have real and equal roots. So if I just draw a line which is passing through the center, or if I draw the line of symmetry, this line of symmetry is equal to the root of the quadratic equation. Here alpha is equal to beta. The two roots that you have are equal. And the third condition that we have discussed was if b square minus 4ac is positive, that means discriminant turns out to be positive, then you have real and unequal roots. That means you have two roots alpha and beta which are actually equidistant from the line of symmetry. So if this is the line of symmetry that I have, alpha and beta, I should mark the line of symmetry carefully. Yeah, alpha and beta would be equidistant from the line of symmetry. So if a is positive, these are, I will get an upward opening thing. If A is negative, I will get a downward opening. Whether it will touch or it will cut will depend upon the value of discriminant. Whether it is equal to 0 or whether it is positive or whether it is negative. If it's negative, it will neither touch nor cut the x-axis because it's a real axis and the roots that you get here are imaginary. So imaginary root will not lie on the real axis. Let's look at an example. What would be the equation of line of symmetry of the following equation? So what is it? You have y is equal to x square minus 2x minus 3. So again, comparing it with the general equation, ax square plus bx plus c. I'll get the value of a as 1, b as minus 2 and c as minus 3. I've got this thing, right? So now I can find out the value of discriminant, which is b square minus 4ac. Imagine this graph is not given to me. This graph is not given to me in the picture. So this will be 4 minus 4 into 3. So this will be 12 and 4, which will be 16. So discriminant, that comes out to be 16, which is positive. That means I will have two distinct roots. Now how do I find the roots? Alpha and beta, if you remember, one thing is I can follow the formula. So if you remember the formula, you can follow the formula, which will be 2 plus minus root of 16, which is 4 divided by 2. So one of the answer would come out to be 6 by 2, which is 3. Another would be 2 minus 4, which will be minus 1. So I'll have minus 1 and 3 is what I will get. So this is minus 1 and this is 3. Now, line of symmetry is a line which is passing through the vertex and is equidistant from it. So if I look at a distance between 1 and 3, I am talking about the distance. It is coming out to be 4 units. So that means the line of symmetry should be 2 units from either side. So this is 2 units. That means x is equal to 1. Sorry. So x is equal to 1. I get the line of symmetry. The line of symmetry, what would be the equation of line of symmetry? I would write it as x is equal to 1. Or I find out the coordinates of the vertex. If you remember this was given by minus b by 2a and minus d by 4. So I can just look for this value only. Minus b by 2a, this is 1. So x is equal to 1 is the equation of line of symmetry. Another question that we have is, in a xy coordinate plane, A and B are different points that have same y coordinates and are on the parabola given by y is equal to x square minus 5x minus 14. What is the x coordinate of the midpoint of AB? So again, if I look at this, the value of A is 1, B is minus 5 and C is minus 14. And if I try to find out the discriminant, which will be 25 minus 4 into 14 that I have. So if I just try to evaluate the discriminant anyways, if I do it, it is coming out to be positive. If discriminant is positive, then that means it will have two distinct roots. And A is also positive, that means it will be a graph like this, which will be cutting the x-axis at 2 points alpha and beta. A and B are the points that have the same y coordinate. Now what do you mean by y coordinate? So y coordinate means if I know this point and this point, here my coordinate is alpha 0 and beta 0. That means the y coordinate is 0 in both the cases. And this is the point which is there on the parabola. So I can take A as one of the root and B as the other root. The question is, what is the x coordinate of the midpoint of AB? Again, the question is asking me the same thing. It is asking me the x coordinate of the line of symmetry. This is given by minus b by 2. I don't need to solve for roots. So this will be 5 by 2. That will be the answer that I have. I should not find out the roots, then find out the midpoint. That is unnecessary. I am wasting my time. So I hope this thing is clear and we'll move ahead with circle. Equation of the circle with center at h and k and radius r would be given as, so this is a circle that you have, would be given as x minus h whole square plus y minus k whole square is equal to r square. So you need to know the center hk and you need to know the radius. So there are two things that you need to know. One is the coordinates of the center and second is the radius. So it will be x minus h whole square plus y minus k whole square equals to r square. Or there's another way in which the equation of the circle can be given. The other way would be x square plus y square plus 2gx plus 2fy plus c equals to 0. Now what I've done is I've just opened up the things and rearranged them to get to this thing. Here, the center of the circle would be given by minus g and minus f. So the center of the circle would be minus g and minus f, and the radius of the circle is given by under root of g square plus f square minus c. So if I just remember both these ways of writing down this equation of the circle, I'll be able to solve any question related to circles very, very easily. Both the equations have their own usage. Let's look at an example. The graph of x square plus y square equal to 100 means it has a center of 0, 0 because it is written as x minus h whole square plus y minus k whole square equal to r square. The radius of such a circle would be 10. Similarly, x minus 6 whole square plus y plus 5 whole square equal to 9 means it's a circle with center as 6 and minus 5 and radius as 3. If you try to draw both these figures, they will intersect at 2 points. Now these 2 points would be the common solution to both the circles. These 2 points will satisfy the equation of both the circles simultaneously. Let's look at another example. Consider the linear function fx is equal to, or fx you already know is literal y is equal to minus 1 by 2x plus 1 and the quadratic equation x square. So you have a quadratic equation y is equal to x square. Now y is equal to x square, if you just find out the value of discriminant, it comes out to be 0. And the value of b is also 0, c is also 0. The value that you have for is only a. So it's an equation, it's a graph that you get like this. And if you draw the other one, there will be this thing. They'll be intersecting at 2 points. Now these 2 points will be a common solution to both the things. So I just need to understand how I should combine a parabola with a linear equation. The other thing that we'll be looking at is the transformations. The graph of minus hx is the graph of hx reflected along x-axis. It's something like, the x-axis act as the line of symmetry. So line of symmetry is x-axis. The graph of minus hx is the graph of hx reflected along x-axis. The graph of h minus x, so if minus is inside, is the graph of hx reflected along y-axis. The graph of hx plus c is the graph of hx shifted upwards by c units. The graph of hx minus c is the graph of hx shifted down by c units. So the graph of h of x plus c. Now this changes inside the function. This changes outside the function. This changes inside the function. Is the graph of hx shifted to c units on the left. This is very, very important to remember. The graph of x minus c. So if the change is inside, it's actually the horizontal change. It's the horizontal thing that will happen. Is the graph that would be shifted c places on the right. If the change is outside the function, it will be a up or down change that I have. the graph of c times hx, that means I'm multiplying it with a constant, is the graph of hx stretched vertically by a factor of c. So I'm stretching it vertically by a factor of c if c is equal to 1. And it should shrink vertically by a factor of c if c is between 0 and 1. So if I'm multiplying a graph with a constant, the graph would be stretched either vertically or shrinked vertically depending upon the factor by which it is getting multiplied. We hope you have enjoyed this video. Please like our video and subscribe to our channel on YouTube. You can visit our website edusathi.com to practice more questions on this topic and access other useful information. Like us and follow us on Facebook and Twitter to get exam-related information and other such updates. We wish you all the best for your preparations. Thank you and have a good day.